A U.S. ally just built a fighter that challenges American air dominance. For years, the Lockheed Martin F-35 Lightning II defined modern air power, so advanced that nations were expected to accept its terms or go without. Then South Korea made a different move. They built their own jet. The KAI KF-twenty-one Boramae isn't just another aircraft. It's a signal of changing dominance. What does it really mean for the F-35's dominance? And why are analysts paying close attention now? Join us as we unveil the capabilities of the KF-21 that just rendered the F-35 obsolete. On paper, the F-35 looks unstoppable. It is described as the most advanced electronic warfare platform ever flown, with sensor fusion that borders on artificial intelligence and a supply chain that spans 45 states and hundreds of contractors. But modern warfare doesn't reward what looks unstoppable on paper. The uncomfortable truth is that the F-35, for all its capability, was designed for a strategic environment that no longer exists. Its development began in the 1990s when the United States assumed it would always have uncontested air superiority in a virtually unlimited budget. The F-35 was built to be the ultimate expression of American air power. A single platform that could replace the A-10, the F-16, the AV-8 Bravo, and the F-18. It was supposed to do everything. In practice, doing everything has come at a cost that is measured not just in dollars, but in availability, sustainment, and strategic flexibility. The F-35 costs approximately $35,000 per flight hour to operate. Its maintenance footprint requires a global network of specialized depots, and its most classified systems, the ones that make it truly dominant, are subject to export restrictions that leave allied nations dependent on American approval for everything from software updates to weapons integration. And that gap is exactly where the problem begins. South Korea began searching for its own indigenous fighter in earnest under a program called KFX, with a single overriding requirement: develop an advanced multi-role fighter that could operate independently of foreign export controls, integrate Korean-made weapons, and be sustained by Korean industry. A fighter that would not ask permission to fly, to fight, or to evolve. That requirement quietly ruled out every foreign fighter on the market. So Korea Aerospace Industries didn't try to buy the F-35. They built something better suited to the future of aerial combat. That is exactly the problem KAI set out to solve with the KF-21 Boramae. Not with a copy of the F-35 or a cheaper imitation, but with a fundamentally different design philosophy. Where the F-35 prioritized absolute stealth at the expense of cost, speed, and maintainability, the KF-21 prioritizes capability in a contested environment where stealth is just one variable among many. This concept was first demonstrated by the KF-21's design choices. Unlike the F-35, which carries its weapons internally to preserve a flawless stealth profile, the KF-21 features 6 internal weapon stations that can carry air-to-air missiles and air-to-ground munitions, but also 6 external hardpoints that can be configured for missions where stealth is less critical than payload. The result is an aircraft that can fight as a stealth fighter when it needs to, and as a conventional bomb truck when it doesn't. An aircraft that is not locked into a single configuration for every mission, but can adapt its signature, its payload, and its role to the specific threat environment. But that flexibility came at a cost. When the KFX program was announced in the early 2010s, the skepticism was overwhelming. South Korea had never built a supersonic fighter. The T-50 Golden Eagle, a supersonic trainer developed with Lockheed Martin, was the extent of its indigenous combat aircraft experience. Building a twin-engine, stealth-influenced multi-role fighter from scratch was considered impossible by most defense analysts. Indonesia joined the program as a partner in 2010, contributing funding in exchange for technology transfer and production rights. Then Indonesia defaulted on its payments. The program continued without them. The South Korean government committed over 8 trillion won, approximately $6 billion, to see the project through. The first prototype, KF-21 No. 1, rolled out of the Sacheon facility in April 2021. The rollout was notable not just for what the aircraft was, but for what it revealed about South Korea's ambitions. The Boramae, which translates to Falcon or Hawk, was presented not as a regional fighter, but as a global competitor. Sleek, powerful, and undeniably modeled on the same stealth-shaping principles that define the F-22 and F-35. By July 2022, the KF-21 had made its first flight. It took off from the Sacheon airfield, climbed through the clouds, and returned 40 minutes later without incident. The flight test program has since accumulated over 2,000 sorties, pushing the aircraft to supersonic speeds, testing its radar, and validating its flight envelope. And then come the numbers. The performance figures the KF-21 has produced during its test phase are striking enough to redefine the aircraft's market position entirely. A top speed of Mach 1.81, faster than the F-35's Mach 1.6, a combat radius of approximately 750 miles, a service ceiling of over 50,000 feet, and a maximum takeoff weight of 25,600 kilograms, making it larger and more capable than the F-16, while remaining significantly cheaper to operate than the F-35. The radar is a domestically developed active electronically scanned array, an AESA radar, with over 1,000 transmit-receive modules. Developed by Hanwha Systems, it represents a capability that only a handful of nations have ever achieved independently. The electronic warfare suite is indigenous. The infrared search and track system is indigenous. The weapons, including the long-range air-to-air missile and the GPS-guided glide bomb, are Korean. The KF-21 is not an assembled collection of foreign components. It is a fundamentally Korean aircraft, built to Korean requirements and subject only to Korean export controls. Consider what this means for the export market. The F-35 is available only to a select group of allies who agree to strict conditions: no independent maintenance, no access to the most sensitive source code, and no ability to integrate third-party weapons without American approval. The KF-21 has none of those restrictions. Poland has already signed a letter of intent to acquire the KF-21. The United Arab Emirates is in discussions. Indonesia remains a partner despite its payment issues. And the list of nations that want advanced fighter capability but cannot afford the F-35's acquisition or sustainment costs is long: the Philippines, Malaysia, Thailand, Colombia, and more. The price is the most disruptive element of the KF-21 equation. Estimates place the per-unit cost between $50 and $65 million. That is approximately half the cost of an F-35 Alpha, the conventional takeoff variant, and roughly one-third the cost of an F-35 Bravo or Charlie. For nations building their air forces on a budget, that difference is the difference between fielding a squadron of stealth-capable fighters and fielding nothing at all. The KF-21's design includes an option for fully internal weapons bays in future production blocks. The current aircraft uses semi-recessed stations for its primary air-to-air weapons, preserving a reduced radar cross-section without the complexity and weight of fully enclosed bays. But the airframe is structurally designed to accommodate internal bays when the technology matures. The Boramae is not a finished product. It is a platform designed to evolve, and that evolution is already planned. Block 1 of the KF-21, currently in flight test, is an air-to-air focused platform with limited air-to-ground capability. It is designed to enter service with the Republic of Korea Air Force in 2026, replacing aging F-4 Phantoms and F-5 Tigers that have been in service since the Vietnam War. Block 2, scheduled for development beginning in the late 2020s, will introduce full air-to-ground capability in the fully internal weapons base. Block 2 will transform the KF-21 from an air superiority fighter into a true multi-role platform, capable of deep strike, close air support, and anti-ship missions. Block 3, currently in the concept phase, will introduce unmanned teaming capabilities, the ability to control loyal wingman-style drones that fly ahead of the manned fighter, absorbing risk, providing additional sensors, and carrying extra weapons. This is the same operational concept that the United States Air Force is developing for the Next Generation Air Dominance program, but the KF-21 is on track to achieve it at a fraction of the cost. None of this means the KF-21 is without risk. The aircraft is not yet in service. Its radar and electronic warfare systems, while advanced, have not been tested in combat. The supply chain for a domestically produced fighter is unproven at scale, and the aircraft's semi-recessed weapons configuration means its radar cross-section, while reduced, is not truly stealthy in the way the F-22 or F-35 are. But unlike the F-35, which required expensive hardware revisions whenever the threat environment changed, the KF-21 uses an open architecture that allows sensors, weapons, and software to be updated without redesigning the platform itself. Where the F-35 matured painfully in hardware, the KF-21 is designed to mature in code. The KF-21 Boramae does not operate alone. It is the centerpiece of a broader transformation in South Korean defense that also includes indigenous airborne early warning aircraft, Korean-made attack helicopters, and a domestic space launch capability. A future Korean air combat wing could see KF-21s carrying the strike element, F-50 light fighters providing local air defense, and Korean-built drones extending the engagement range without risking a single additional pilot. All of this matters because the United States and its traditional allies have spent decades assuming that only American industry could produce fifth-generation fighters. They assume that the barriers to entry, the stealth expertise, sensor integration, and propulsion technology were simply too high for any other nation to clear. The KF-21 breaks every one of those assumptions. The first production aircraft are scheduled to enter service with the Republic of Korea Air Force by the end of 2026. The flight test program has already cleared supersonic flight, weapons separation, and radar performance validation. The production facility in Sicheon is tooled and ready, and KAI has already committed to expanding its export marketing efforts across Asia, the Middle East, and South America. The impossible fighter, the aircraft that was supposed to be too complex, too expensive, and too advanced for a nation with no prior fighter development experience, is becoming the standard. The fundamental insight that an aircraft combining advanced sensors, reduced observability, and affordable sustainment creates strategic independence that no amount of pure stealth can match will remain valid regardless of how the technology evolves. The KF-21 is the first full expression of that idea at operational scale, but it won't be the last. Because this isn't just a cheaper F-35, it's the moment the monopoly on fifth-generation fighter technology stops being absolute. For 2 decades, the F-35 has defined what it means to be a fifth-generation fighter. Expensive, exclusive, and dependent. South Korea just built the alternative. The United States F-35 is unlike any other fifth-generation fighter jet. Since the 1990s, this technological marvel has dominated the skies with its advanced technologies and unmatched capabilities, making it nearly unbeatable. But what really sets it apart is its remarkable ability to take off vertically. How does it achieve such impressive feats, and what makes this aircraft stand out from other fifth-generation jets? Join us as we reveal the amazing performance of the F-35, showing its incredible ability with a vertical takeoff. During the late 1990s and early 2000s, the development of the F-35 was deemed important because it introduced a new set of advanced systems that set a new standard in combat aircraft design. As part of the Joint Strike Fighter program, the F-35 was created to meet the specific needs of both the Navy and Air Force. Several international partners, including the United States, Italy, Denmark, Norway, and the Netherlands, were involved in the program. In the late 1990s, both Lockheed Martin and Boeing competed with their concept demonstrators, with Lockheed ultimately winning, leading to the development of a technological marvel, the F-35, the Lockheed Martin F-35. Lightning II is an American fighter jet with 1 seat and 1 engine, built for high speed and stealth missions. This aircraft is very unique because it can handle different roles, like air combat, striking ground targets, electronic warfare, and gathering intelligence. This aircraft is designed to reach exceptional speeds of Mach 1.6, or 1.6 times the speed of sound, even while carrying a full internal payload. With almost twice the internal fuel capacity of the F-16 Fighting Falcon, the F-35 has an extended combat radius. Due to its advanced weaponry, it is heavier than earlier lightweight fighters, with the lightest variant weighing over 29,000 pounds when empty. It comes in 3 versions: the conventional takeoff and landing F-35A, the short takeoff and vertical landing F-35B, and the carrier-based F-35C. One of the most significant upgrades in the F-35 is its advanced technology. Built using lessons from the F-22 Raptor, it features sophisticated sensors and avionics. Its open architecture allows for continuous updates and improvements over time. Amidst its mind-blowing features, this aircraft stands out for its ability to take off and land vertically. This unique feature allows it to operate from diverse locations like aircraft carriers, small airfields, and even urban areas, making it highly adaptable. The F-35 ability to take off and land vertically relies on its powerful engine and a special lift fan. Located at the rear, this lift fan is powered by the same engine that propels the aircraft forward. When activated, the fan pushes air downwards, generating enough lift to allow vertical takeoff. Here's how it works. The pilot activates the lift fan, which directs air downward to create an upward force. This, combined with the engine's thrust, lifts the aircraft vertically. Once it's airborne, the pilot shifts from vertical to horizontal flight. This vertical takeoff capability offers many advantages. The F-35 can launch from a wide range of locations, including small airfields and aircraft carriers, giving it great operational flexibility. It also doesn't need a long runway, reducing the need for infrastructure. Additionally, it can operate in remote or dangerous areas, making it harder for enemies to target. While this capability is quite impressive, this aircraft's design is also intriguing. Let's explore the features of this fight generation masterpiece. Stealth is a huge part of the F-35 design. To stay hidden from its enemies, the jet's body is carefully shaped, with smooth curves and aligned edges to deflect radar waves, and it's coated with radar-absorbent materials. Its unique air intake design, called the diverterless supersonic inlet, keeps the engine hidden from radar while letting air in efficiently. This stealth setup makes the F-35 appear as small as a golf ball on radar at certain angles, and can sometimes even rival the stealth of the F-22. The aircraft also uses special coatings that are more durable than older stealth jets, meaning they need less upkeep. It has reduced infrared and visual signatures and tightly controls radio signals to avoid detection. The F-35 is primarily stealthy against high-frequency radar, though low-frequency radars can still detect it. But those are less precise and easier to spot. This technological marvel can also attach special reflectors to make itself visible when needed. However, there is one area where the F-35 falls short: its noise. At bases in places like Arizona and Florida, the sound has raised concerns. While its noise level is similar to older jets like the F-16, the F-35 lower frequency rumble is more noticeable. Some studies suggest its noise isn't much louder than the F-16 or F/A-18, but the deeper vibrations are easier to feel, making it stand out more. Despite this, the F-35 mission systems are among its most impressive features, showcasing cutting-edge technology that greatly enhances its performance. Bringing together a complex mix of sensors and software, these systems provide pilots with a powerful edge in battle. From radar to electronic warfare and advanced targeting cameras, every component works seamlessly to offer a complete view of the battlefield, boosting the pilot's awareness and ability to control missions in high-tech, networked warfare. The software behind this is huge, with over 8 million lines of code. Using common parts helps make updates easier and more affordable across the fleet. This high-level software, especially the parts that merge data from different sensors, took time to develop and caused some delays in the F-35 program. The F-35's radar and sensor systems are packed with advanced tech to help pilots see and respond to threats quickly and accurately. The APG-81 radar can track multiple targets over 150 kilometers away and is angled for stealth. Working with it is the AAQ-37 DAS, which uses 6 infrared sensors to give a full 360-degree view, alerting the pilot to incoming missiles and providing infrared night vision directly to their helmet. The ASQ-239 Barracuda electronic warfare system adds even more defense, with 10 antennas around the jet for warning and jamming enemy radars. This system also helps pilots pinpoint threats and deploy countermeasures. The AAQ-40 under the jet's nose enables laser targeting and long-range infrared tracking, while the ASQ-242 CNI suite allows the F-35 to send information to other planes without compromising stealth. The F-35 is built to upgrade over time, with improvements like the upcoming Technology Refresh 3, which adds a faster processor and better display. Future upgrades include a new radar, the APG-85, and possibly an advanced EOTS. The F-35 could even direct unmanned drones in the future, coordinating attacks using its advanced sensors and communications. Let's move on to where the action is: the cockpit. The F-35 cockpit is designed to keep the pilot fully aware and in control. It features a large 20 by 80-inch touchscreen display showing flight data, weapons, communications, and alerts, which the pilot can arrange to their preference. A smaller screen below acts as a backup. Instead of a traditional head-up display, important flight and combat info appears on the pilot's helmet visor. The cockpit includes voice control, a one-piece tinted canopy with a strong internal frame, and a Martin Baker ejection seat with a twin catapult system for emergencies. The F-35 has a side stick and throttle setup, and for life support, it has an onboard oxygen generation system powered by the jet's main power system, with extra oxygen available for emergencies. The helmet display is a standout feature, putting crucial flight and combat info right on the pilot's visor so they can see it no matter where they're looking. This helmet, called the HMDS, even shows infrared and night vision images, letting the pilot see through the jet itself. With the HMDS, pilots can target and fire missiles at objects without needing to face directly toward them. Each helmet costs a hefty $400,000 and is a bit heavier than standard helmets, which raises safety concerns for lighter pilots during ejection. The helmet's early versions had issues like shaking, blurry vision, and night vision problems. To address this, Lockheed Martin and Elbit considered a backup helmet, working with BAE Systems to develop one in 2011. However, after improvements to the HMDS, the backup plan was dropped in 2013. By 2016, a Gen 3 version of the helmet was introduced with better night vision, clearer displays, auto alignment, and software upgrades. To keep its stealthy shape, the F-35 stores weapons inside two internal bays, each with two stations. The outer stations can hold larger weapons, up to 2,500 pounds for most versions, or 1,500 pounds for the F-35B. These stations can carry powerful bombs and missiles like JDAMs, paveway bombs, and joint standoff weapons. They can also hold several smaller bombs, like the GBU-39 small-diameter bomb, with up to 4 per station for the F-35A and F-35C, and 3 for the F-35B. The inner stations are for air-to-air missiles, like the AIM-120 AMRAAM, and in the future, the AIM-260 JATMR. As of October 2023, the F-35A can also carry the B-61 Mod 12 nuclear bomb. Behind the weapon bays, the F-35 has compartments for countermeasures like flares, chaff, and decoys, adding extra protection during missions. When the F-35 doesn't need stealth, it can carry more weapons on 6 external stations. The wingtip pylons each hold an AIM-9X or AIM-132 ASRAAM missile, angled to keep the aircraft's radar profile low. Each wing also has larger stations that can carry heavier air-to-surface missiles, like the AGM-158 JSSM and LRASO cruise missiles. With internal and external stations, the F-35 can load up to 8 AIM-120 air-to-air missiles and 2 AIM-9s, or a combination of bombs and missiles for ground and air targets. The F-35A has a 25mm GAU-22/A rotary cannon inside the left wing root, ideal for ground targets and more powerful than other USAF fighter guns. The F-35B and F-35C versions use a special multi-mission pod for the gun, which can also carry equipment for different roles like electronic warfare and reconnaissance. Future upgrades are underway. A sidekick rack will boost the internal missile capacity, and new Block 4 improvements will let the F-35B carry more bombs. The aircraft may also integrate new weapons like the AGM-88G AAR-GMER, hypersonic missiles, and even laser weapons. The USAF plans for the F-35A to handle close air support missions, especially in tough contested areas. Despite some critics saying it's not as good as a specialized attack plane, USAF Chief Mark Welsh emphasized the need for effective weapons in CAS roles. This includes guided rockets, fragmentation rockets that break into many small projectiles before hitting, and smaller ammo for gun pods with higher capacity. Fragmentation rockets are particularly powerful, delivering a 1,000-round burst that creates more impact than a traditional strafing run. The F-35 is powered by a single Pratt & Whitney F-135 low-bypass augmented turbofan engine. It produces 28,000 pounds of thrust at military power and 43,000 pounds with the afterburner engaged. The F-135 is based on the F-22's F-119 engine, but features a larger fan and higher bypass ratio, improving subsonic thrust and fuel efficiency. Unlike the F-119, the F-135 is not designed for supercruise. A key feature of the F-135 is its stealthy afterburner, which incorporates special fuel injectors and curved vanes covered in ceramic radar-absorbing materials. These features help hide the turbine from enemy detection. During its early development, the afterburner experienced issues with pressure pulsations, or screech, at low altitudes and high speeds. The engine's low observable nozzle has 15 partially overlapping flaps that create a sawtooth pattern at the trailing edge. This design reduces the aircraft's radar signature and also creates vortices that lower the infrared signature of the exhaust plume. Due to the engine's large size, the U.S. Navy had to adjust its underway replenishment system to ensure the F-35 could be supported during at-sea logistics. The F-35 integrated power package combines multiple systems into one, handling power and thermal management, as well as the environment control, auxiliary power unit, engine starting, and other essential functions. The F-135 PW600 engine for the F-35B includes a shaft-driven lift fan that enables the aircraft to take off and land vertically. This system, developed by Lockheed Martin and Rolls-Royce, includes the lift fan, a drive shaft, 2 roll posts, and a unique 3-bearing swivel module, or the 3BSM. The 3BSM nozzle has 3 bearings shaped like a short cylinder, and as the motor spins the edges, the nozzle swivels from a straight line to a perpendicular position. This allows the engine's exhaust to be directed downward at the rear of the plane, providing vertical thrust. The nozzle is moved by a fuel-hydraulic actuator, which uses pressurized fuel for movement. Unlike the Harrier, which relies entirely on engine thrust for lift, the F-35B combines the nozzle's thrust with the lift fan. The fan is powered by the engine's low-pressure turbine through a drive shaft and is located near the front of the plane to balance out the force from the nozzle. For roll control during slow flight, the F-35B uses roll posts mounted on the wings that direct engine bypass air to help steer the plane. In the 1990s and 2000, an alternative engine for the F-35, the General Electric/Allison/Rolls-Royce F-136 was being developed. The F-136 was based on the General Electric YF-120 engine and was said to have a higher temperature tolerance than the F-135 due to its design, which made better use of the engine's airflow. However, the F-136 project was canceled in December 2011 due to a lack of funding. The F-35 is expected to receive engine upgrades over time to meet new threats and improve performance. In 2016, the Adaptive Engine Transition Program was launched to explore adaptive cycle engines with the goal of re-engineering the F-35. By 2016, both General Electric and Pratt & Whitney received contracts to develop 45,000-pound forced thrust engines, called XA-100 and XA-101. While these new engines could potentially replace the F-35 current engine, Pratt & Whitney is also improving the F-135 with the engine core upgrade, which enhances thrust, fuel efficiency, and cooling capacity by 5% and 50% respectively to support future upgrades. In 2023, the USAF chose the F-135 ECU over the AETP engines due to concerns about the cost and risks of the XA-100, even though it could have entered service by 2027. One thing that gives the aircraft an edge over other airfighters is that it is designed to be easier to maintain than older stealth aircraft. About 95% of the parts that can be replaced in the field are accessible with just one step, meaning nothing else needs to be taken out to reach the part. For example, the ejection seat can be replaced without having to remove the canopy. The F-35 also uses a radar-absorbing material that is stronger, easier to handle, and dries faster than older coatings. This new material could be used on other stealth aircraft, like the F-22 to help improve durability. The F-35 skin is designed to reduce corrosion, using better filler and drainage than the F-22. The flight control system is powered by electro-hydrostatic actuators instead of traditional hydraulic systems, and lithium-ion batteries can take over in emergencies. The USMC's first aircraft maintenance field training detachment used the lessons from the USAF to improve their F-35 operations by taking advantage of the common features across all variants. The F-35 was originally supported by a system called analysts, which was meant to track parts and allow any F-35 to be serviced anywhere. However, analysts faced many problems, like unreliable diagnoses and security issues. As a result, it's being replaced by Odin, a more efficient, cloud-based system. Odin started replacing analysts at various military bases in 2020, and by 2022, multiple sites had transitioned to Odin. The new system performs twice as well as analysts, offering improved reliability and efficiency. While the F-35 Lightning II is still considered one of the most powerful fighters in the world, the U.S. Air Force is already planning ahead with its next-generation air dominance program. Although there's no exact definition for fifth-generation aircraft, experts agree that stealth is a key feature. While the F-35 is expected to remain a dominant force in the skies for many years, the U.S. Air Force is already focusing on its next-generation strategy. First envisioned in 2014, the NGAD Next Generation Air Dominance Program aims to ensure continued air superiority. The fighter's design will center on 5 key technologies: advanced weapons, stealth, digital design, propulsion, and thermal management. Although the exact definition of 6th-generation technology is still unclear, the features that would be included in the NGAD program are expected to surpass the capabilities of current 5th-generation fighters. One of the most significant changes will be the integration of artificial intelligence and unmanned aerial vehicles into the NGAD. These unmanned systems are expected to work alongside a 6th-generation fighter jet, creating a more dynamic and flexible combat force. In fact, the United States Air Force is moving away from the traditional idea that a fighter jet must always be a single crewed aircraft. This shift in thinking is also being explored in Beijing, where China is looking into similar concepts. Although the United States was the first to introduce a 5th-generation fighter, it may not be the first to deploy a 6th-generation successor in the skies. The Air Force has revealed that demonstrator NGAD aircraft are already taking to the skies, and a contract for its official development could be awarded within the next year. As reported by Breaking Defense, the Department of the Air Force issued a classified solicitation to industry for an engineering and manufacturing development contract for the next-generation air dominance platform, with plans to award the contract in 2024. Given the current security threats, launching the military's next-generation fighter program is crucial for maintaining America's air superiority. Can the United States F-35 withstand the threat of Chinese hypersonic weapons? Recent advancements in China's hypersonic technology have raised global concerns, sparking questions about whether the United States is losing its technological edge. Does the U.S. have the capability to counter these hypersonic threats, or is it at risk of falling behind in this critical area of defense? Join us as we delve into the groundbreaking comparison of 2 ultimate weapons, the F-35 versus Chinese hypersonic threats. China is making fast progress in hypersonic missile technology, putting it at the forefront globally and raising concerns in the United States. One major example of their advancements is the DF-17 missile, which is designed for speed and precision. It is a medium-range ballistic missile that uses solid fuel and is road mobile, meaning it can be transported and launched from various locations. They have also made breakthroughs in thermal protection and cooling systems, which are crucial for managing the intense heat these missiles generate during flight. These developments give China a clear technological advantage, showing their growing strength in modern military innovation. It's certain that they are not stopping anytime soon, because they recently achieved another major breakthrough in hypersonic missile technology, particularly with its thermal protection system. Chinese scientists have made significant improvements by adding steel nose cones to their new missiles. This advancement is crucial because it enhances the missile's ability to survive the extreme conditions it faces during flight. In August, China also announced the development of an innovative cooling device designed to manage the intense heat generated during hypersonic flight. Hypersonic missiles travel at incredibly high speeds, which results in a huge buildup of heat. Without proper cooling, this heat could damage the missile's guidance system, affecting its accuracy and performance. With the new cooling technology, the missile is better equipped to withstand these extreme temperatures, making it less likely to malfunction. This improvement allows the missile to fly more effectively and remain undetected, increasing its chances of successfully reaching and eliminating its target. These technological advances are a significant step forward for China's hypersonic missile program, giving it a performance edge in the field of modern warfare. As the race for advanced weaponry intensifies, these innovations could change the future of missile technology and warfare. One member of Congress is raising concerns. Representative Doug Lamborn, who is part of the House Armed Services Committee, held a hearing for a subcommittee this spring. The mood was serious. One expert on the panel said the United States is clearly falling behind China. Jeffrey McCormick, an intelligence analyst with the Defense Intelligence Agency, stated that China now has the world's leading hypersonic arsenal. The United States still has reason for optimism. Surprisingly, one of the best American hypersonic missiles is being developed by the U.S. Army. Known as the Long-Range Hypersonic Weapon, or by its nickname, the Dark Eagle, this missile has impressive capabilities. It can travel at speeds exceeding 3,008 human miles per hour and has a range of 1,722. The Dark Eagle uses a road-mobile launcher, a feature also preferred by China for its missiles, making it a highly versatile weapon. According to the Army, the missile can fly to the top of the Earth's atmosphere and stay just out of reach of air and missile defense systems until it's ready to strike. By the time it's within range, it's already too late to react. Despite China's advancements, all is not lost for the U.S. The race to develop hypersonic missiles is critical, as China has made remarkable progress in this area. Their scientists have been steadily advancing hypersonic technology and already have fast, maneuverable missiles deployed. China's military continues to look for ways to improve these weapons, and its rapid progress is something the U.S. must be prepared to match. However, the United States is not far behind, and with the right focus and commitment, it can catch up to China. The issue lies in the way the U.S. military approaches hypersonic development. While China has been able to make steady, incremental advances in their missile technology, the United States has focused on separate programs across various branches of the military. This lack of coordination could slow progress. In contrast, China's approach is more streamlined, allowing them to make faster improvements and field more advanced systems. There's still a chance for the U.S. to regain its lead, but it will require strong, focused efforts. We have yet to experience a Sputnik moment where China might test a hypersonic missile in a high-profile launch that demonstrates its serious intentions to use these weapons for strategic purposes. A launch over Guam, for example, could be a powerful signal to the world of China's capabilities and intentions. Until such a moment happens, policymakers like Representative Doug Lamborn, who is raising concerns about the state of U.S. military technology, are crucial. They are pushing for the U.S. to stay focused on developing advanced hypersonic systems to counter China's growing missile capabilities. While there have been some obstacles and challenges in the development of American hypersonic weapons, the U.S. defense industry is known for its strength. With continued investment, collaboration, and focus, it's likely that the United States will catch up to China in this critical area of military technology. The arms race is far from over, and with the right strategy, the U.S. could still emerge as the leader in hypersonic missile technology. This leads us to one important question. Can the F-35 withstand the lethality of the Chinese hypersonic threat? Let's analyze the strength of this American airfighter. The F-35 Joint Strike Fighter is one of the most recognizable fighter jets in the world. Since it began service, this American-made fifth-generation aircraft has flown over 777,000 hours. Currently, 20 nations use the F-35, making it a vital tool for the U.S. and its allies. For years, the U.S. held air superiority with the introduction of the F-22 Raptor. However, both China and Russia now have their own fifth-generation jets and are working on sixth-generation designs. For now, the F-22 and F-35 remain America's top fighters. The F-35 mission systems are like the brain and eyes of the jet, making it one of the smartest aircraft ever built. Packed with advanced sensors and software, These systems give pilots a complete picture of their surroundings, making the jet a powerful tool in modern warfare. Key components include the APG-81 radar, which can track multiple targets over 150 kilometers away, and the Barracuda electronic warfare system, which can detect, jam, and protect against enemy radars. The jet also features a cutting-edge distributed aperture system with 6 infrared cameras that provide a full to 60-degree view, even at night. All this information is fused into a single clear display for the pilot, giving them unmatched situational awareness. Future upgrades include improved sensors, a more powerful radar, and even the ability to control drones during missions. With these advancements, the F-35 isn't just a fighter jet. It's a flying command center built for the future of air combat. Stealth is one of the F-35's most impressive features, making it hard for enemies to detect. Its unique design includes smooth, curved surfaces, precisely aligned edges, and radar-absorbing materials to minimize radar detection. Even the engine is cleverly hidden from view. The jet's advanced air intake system, called the diverterless supersonic inlet, further reduces its radar signature by eliminating gaps that could reflect signals. Remarkably, the F-35 radio cross-section is so small that it's been compared to the size of a metal golf ball from certain angles, even outperforming the stealthy F-22 in some scenarios. Its outer skin, made from durable, radar-absorbent material, is designed to last longer and require less maintenance than older stealth aircraft like the F-22. The F-35 also reduces its infrared and visual signatures, making it harder to spot by heat or sight. It carefully manages its radio signals to avoid detection. While low-frequency radars can sometimes detect stealth aircraft, they are bulky, imprecise, and easy to locate, giving the F-35 a significant advantage. For training purposes, it can even use special reflectors to temporarily increase its radar signature. Its cockpit is like something out of a sci-fi movie, designed to give pilots maximum awareness and control. At its heart is a massive 20 by 8-inch touchscreen display, which shows everything from flight data to weapon systems and alerts. Pilots can customize the layout to fit their needs, making it incredibly user-friendly. Beneath this display is a smaller backup screen for emergencies, while advanced voice recognition technology allows hands-free commands. Unlike older jets with head-up displays on the dashboard, the F-35 uses a state-of-the-art helmet-mounted display system. This helmet projects flight and combat information directly onto the pilot's visor, so they can see critical data no matter where they're looking. It even integrates infrared and night vision, allowing pilots to see through the plane for incredible situational awareness. The helmet is so advanced that pilots can lock onto targets and fire missiles without pointing the aircraft directly at them. Each helmet costs a whopping $400,000, but its capabilities are game-changing. While the HMDS had some growing pains, like issues with vibration and night vision early on, it's now more reliable than ever. The latest version boasts improved cameras, sharper displays, and advanced alignment features. The F-35 cockpit and helmet work together to give pilots an unmatched edge in the skies, blending cutting-edge technology with pilot-friendly design. Without going on and on about the capabilities of the F-35, to answer the question, it is unlikely for this American aircraft to be able to directly withstand a hit from a modern Chinese hypersonic missile due to their extreme speed, maneuverability, and difficulty in detection, making them very hard to intercept with current technology. What is the United States Air Force doing concerning the threat that these Chinese hypersonic Air Force pose? The United States Department of Defense is ramping up spending on hypersonic weapons after years of warnings that China is pulling ahead in this technology. However, this new arms race comes with risks, especially as relations between the US and China continue to worsen, and there's limited information about China's advancements in this field. Hypersonic weapons, which travel faster than Mach 5, aren't a new concept. The US has been testing them since the 1950s, but investment in these systems slowed over the years. Meanwhile, China and Russia have made significant progress in their hypersonic programs. Russia recently demonstrated its capability by using 6 hypersonic Kinzhal missiles in Ukraine, the largest single deployment of these weapons during the war. Other nations, including Australia, South and North Korea, Japan, India, and Germany, are also developing hypersonic weapons. The US is now increasing funding and efforts to catch up, But the timing is tense, with US-China relations at their lowest point in decades. This competition could shape the future of global military power. The U.S. Department of Defense reportedly plans to allocate $15 billion for hypersonic weapons development for the Army and Air Force between 2023 and 2027, as highlighted in a Congressional Budget Office report. This figure excludes the Navy's program, which recently awarded a $1.1 billion contract to Lockheed Martin for integrating hypersonic systems into Zumwalt-class destroyers. Experts have indicated that the U.S. may be lagging behind China in this field. Reports noted that China's 2021 test of a nuclear-capable hypersonic weapon surprised many in the defense sector, showcasing advanced capabilities that exceeded expectations. It has been suggested that America's previous technological dominance, once considered untouchable, is now being challenged by China's progress. Observers have pointed out that this shift has spurred the U.S. to accelerate its efforts in several areas. Concerns have also been raised about the absence of treaties governing hypersonic weapons, a situation some believe could lead to global instability, as seen during the Cuban Missile Crisis. However, analysts have noted that the major powers in this domain appear unwilling to pursue such agreements at present. Despite challenges, U.S. defense officials, lawmakers, and weapons manufacturers continue to advocate for hypersonic technology, with the government now committing significant funding to advance the project. Hypersonic weapons are undeniably expensive, but they offer unique advantages that justify the investment. The U.S. military began exploring hypersonic systems as far back as the 1960s, initially focusing on hypersonic flight for transporting people rather than weapons. By the 1980s, however, the focus shifted. During this period, the Air Force tested the maneuvering reentry vehicles, demonstrating that missiles traveling at speeds of Mach 5 or faster could be guided precisely to their targets as they re-entered Earth's atmosphere. The early 2000s marked a turning point when the U.S. began serious efforts to develop hypersonic weapons under its Conventional Prompt Global Strike program. Today, two primary types of hypersonic weapons are being developed: glide vehicles and air-breathing missiles. Glide vehicles are launched on rockets and glide through the atmosphere at high speeds, while air-breathing missiles use engines to sustain their hypersonic speeds. Although U.S. hypersonic systems are designed to carry conventional payloads, other nations, such as China, are pursuing nuclear-capable hypersonic weapons. This was evident during China's groundbreaking 2021 tests, which demonstrated the ability to combine nuclear warheads with hypersonic speeds, raising concerns about the global arms race. As the U.S. pushes forward, these advanced systems promise unparalleled speed, precision, and flexibility in modern warfare, making them a critical focus for defense strategies. China has long sought ways to counter U.S. missile defense systems, viewing them as a threat to its nuclear deterrence, according to Lyle Morris, a senior fellow at the Asia Society Policy Institute. Since the early 2000s, China has significantly boosted its hypersonic weapons program, especially after the U.S. withdrew from the anti-ballistic missile treaty with the Soviet Union. With no restrictions on developing anti-ballistic systems, China felt compelled to develop a different kind of deterrent. One key focus of China's efforts has been glide-type hypersonic weapons. These systems start their journey atop a ballistic missile, explains Timothy Heath, a defense researcher at the RAND Corporation. Once the missile reaches a certain altitude, the hypersonic glider detaches and travels at incredible speeds within the atmosphere. Unlike traditional ballistic missiles that follow a fixed trajectory, the glider can maneuver in flight, using the momentum from its launch to strike its target with precision. China claims its hypersonic weapons are ready for deployment, which Heath notes is a step or two ahead of the U.S., whose hypersonic program is still in the testing phase. This progress isn't surprising given China's advanced ballistic missile program and the U.S.'s relative underinvestment in similar technologies over the years. The real game changer with hypersonic weapons isn't just their speed, but their ability to maneuver and evade missile defense systems like the Patriot. These systems, widely used in the U.S. and 17 other countries, struggle to track and intercept hypersonic weapons due to their unpredictable flight paths and the ability to skim the edge of the Earth's atmosphere before re-entering. According to defense experts, hypersonic weapons could potentially outmatch even the most advanced air and missile defense systems in the near future, making them a significant development in modern military technology. With China's successful hypersonic missile tests and rising tensions between Beijing and Washington, it's understandable to worry about the rapid pace of weapons development and heated rhetoric. However, there are significant obstacles to the widespread use of hypersonic weapons in combat. The high cost, around $15 million to $18 million per missile, combined with the practical realities of warfare, where basic weapons like artillery are often more effective, makes their use in battle questionable. Experts like Lyle Morris and Timothy Heath are skeptical about hypersonics' actual usefulness on the battlefield. A report from the Congressional Research Service points out that critics believe these weapons don't have clear mission roles, don't significantly improve U.S. military capabilities, and aren't necessary for deterrence. In addition, there's concern that China might share its hypersonic technology with other U.S. adversaries, such as North Korea, Iran, and Russia, all of which are developing their own hypersonic programs. As China and Russia strengthen their defense and technological ties, sharing knowledge on hypersonics wouldn't be surprising, says Elsa Kania, an expert on national security. One of the main concerns about China's hypersonic program is that the U.S. might be caught off guard. The fear of appearing less dominant in defense was especially strong after China's successful missile tests in 2021. General Mark Milley, chairman of the Joint Chiefs of Staff, called these tests China's Sputnik moment, drawing a comparison to the Soviet Union's 1957 launch of the first artificial satellite, which shocked the U.S. Despite the concerns, Heath argues that hypersonic weapons would not be the deciding factor in a conflict between the U.S. and China or any other nation with hypersonic capabilities. The U.S. has a significant edge in other military technologies like stealth aircraft, long-range bombers, aircraft carriers, and submarines, conventional forces that allow the U.S. to project power and dominate adversaries without relying on long-range missiles. As the U.S. continues to invest in hypersonics and other nations develop their own capabilities, it's crucial to establish some sort of agreement on how these weapons should be used in combat. Unfortunately, Morris notes, this may not happen until a major escalation forces both sides to confront the issue. With the current lack of communication between China and the U.S. military, the risk of misunderstandings or miscalculations is high. Furthermore, most significant weapons agreements have historically been between the U.S. and Russia. With Russia pulling out of the New START treaty, the last major nuclear arms control agreement, the hope for any future defense technology agreement seems distant at best. The F-35 might just be getting the biggest upgrade in modern fighter jet history. While most people think the future of air combat means building brand new sixth-generation fighters from scratch, Lockheed Martin is taking a completely different approach. Instead of starting over, they are pushing the F-35 to its absolute limits, adding cutting-edge technology that could rival jets that haven't even been built yet. What kind of firepower would the upgraded F-35 carry, and how do they give the United States an edge over other countries in battle? Join us as we dive into Lockheed Martin's plan and whether their evolution over revolution approach can actually work. In military aviation, there is always a debate: push for brand new tech or keep improving what already works. Lockheed Martin isn't sitting around talking about it. They are upgrading the F-35 to pack in features that edge it closer to sixth-generation fighter capabilities. It's a bold move that leans into evolution over reinvention. Interestingly, the company compares the F-35 to a NASCAR race car, not because it's flashy, but because it is being fine-tuned for peak performance. Instead of building something entirely new, they are squeezing every bit of potential out of a proven platform. The big question now is whether this strategy can hold up against next-gen competition, like Boeing's upcoming F-47. Boeing's F-47 is shaping up to be the Air Force's next big step in fighter jet development. It's part of the Next Generation Air Dominance program, which has been focused on finding a replacement for the F-22 Raptor. This new aircraft is being built with air superiority in mind and could end up being the first sixth-generation fighter in the United States military. The Air Force is planning to acquire at least 185 units of the aircraft, with the final count subject to adjustments depending on funding and operational needs. Design targets include a combat radius of over 1,000 nautical miles, allowing for long-range strike missions and sustained patrol coverage. Projected top speed is set to exceed Mach 2, continuing the tradition of high-velocity performance seen in previous United States air superiority platforms. Despite this plan, the F-35's development kicked off in the mid-1990s under the Joint Strike Fighter program, which set out to build one aircraft that could handle missions across different branches of the military. The first prototype, called the X-35, flew for the first time in October 2000, showing that the concept had real potential. After that, it took another 5 years of engineering and testing before the first full production model, the F-35A, was ready to fly. That flight marked a major step forward, proving the program's goals could be met with a fully functional aircraft. From the start, the team behind the F-35 set out to build a flexible fighter jet that could take over for most of the United States military's existing aircraft, with different versions designed for each branch. Unlike the F-22 Raptor, which was built for a more specific role, the F-35 Lightning II got its name as a nod to the Lockheed P-38 Lightning from World War II, a way to link today's technology with a legacy of past innovation. The project also brought in a wide range of international partners, aiming to make the jet the most widely used fighter across global military forces. Lockheed Martin's plans for the F-35 have delivered strong results, with key milestones showing how widely the aircraft has been adopted. In early 2024, the company marked a major moment by finishing the 10,000th F-35 airframe. That figure highlights how much demand the jet has generated across military forces around the world. Fifth-generation fighters stand apart from earlier models not just because of their stealth-focused design, but because of the advanced computer systems running inside. The F-35 in particular is often described by engineers as a flying computer, thanks to the level of onboard processing power that drives its performance. If anyone asks around at Lockheed Martin about the toughest part of building the F-35, mission systems tend to come up first. That makes sense, considering the Block 3F software needed over 8 million lines of code just to run. The scale of that complexity becomes even clearer when looking at the upcoming Block 4 update, which pushes things even further in terms of computing power and system capability. The Block 4 upgrade is being rolled out in stages from the late 20s through the mid-30s to keep systems running smoothly and maintain full operational performance. The update adds a range of improvements to the F-35, including new weapons built for the platform, specialized armaments for international users, upgraded sensors for improved situational awareness, and the AN/APG-85 radar system with better detection and tracking capabilities. The upgrade also adds stronger electronic support systems to help the aircraft spot and respond to threats more effectively. Video data sharing has been improved to support better coordination with other units. One of the biggest changes is the shift to agile software development, which speeds up how updates and improvements are delivered compared to older methods. A major part of the Block 4 upgrade is Technology Refresh 3, or TR3. It brings faster processors and more memory to the F-35, making it better equipped to handle complex missions and advanced computing tasks. This update keeps the aircraft responsive and reliable under demanding conditions and sets the stage for future upgrades as mission needs and threats continue to evolve. Lockheed Martin is working on upgrades to the existing Pratt & Whitney F-135 engines used in the F-35 fleet, while also looking into adaptive engine technologies. These new systems are designed to change performance settings on the fly, depending on mission needs and operating conditions. The Adaptive Engine Transition Program, or AETP, was launched in 2016 to push development of next-generation propulsion systems. In 2018, Pratt & Whitney received contracts to build two experimental engines, the XA-101 and XA-100, each rated at 45,000 pounds of thrust. By 2021, the program had made solid progress toward changing how fighter aircraft engines are built and perform. The Adaptive Engine Initiative was restructured and rebranded as the Adaptive Engine Development Program, expanding its scope to cover a wider array of military aircraft instead of concentrating on just one. In 2022, the Air Force launched the F-35 Adaptive Engine Replacement Program to begin readying both the aircraft and its infrastructure for future integration of these advanced propulsion systems once they reach operational maturity. In 2023, military leadership chose to focus on upgrading the current F-135 engine through a program called the Engine Core Upgrade, or ECU, instead of moving forward with brand new engine designs right away. The Engine Core Upgrade brings notable gains in key performance areas, boosting thrust and fuel efficiency by 5% and improving cooling capacity by 50%. These changes are essential for meeting the demands of the Block 4 feature set. The upgraded cooling system is critical due to the increased heat produced by the advanced systems in Block 4. Without proper thermal management, extended missions could see reduced performance and reliability. The ECU method delivers immediate improvements while keeping the existing engine platform intact, sidestepping the risks tied to adopting entirely new propulsion technology. The Air Force has held off on swapping out the F-35's engines for the experimental XA-100 models from the adaptive engine programs. That doesn't rule out the possibility of upgrades later on, possibly in the 30s or 40s, once the technology is fully developed. For now, these adaptive engines are expected to first appear in the Next Generation Air Dominance Fighters, or NGAD. Designing those aircraft around the engines from the start makes it easier to fully integrate the new propulsion systems, rather than trying to retrofit them into platforms built for older technology. Before any new engines show up, the F-35 is expected to start working alongside a range of unmanned aerial vehicles that expand its role across different mission types. Lockheed Martin's Skunk Works is behind Project Carrera, which includes the Speed Racer drone. Each unit runs about $1 million and is built for advanced electronic warfare and reconnaissance. These drones are meant to operate in sync with manned fighters like the F-35, allowing one pilot to manage several platforms at once while still relying on human decision-making in high-stakes combat scenarios. Aerial combat is shifting toward integrated teams where F-35 jets operate with advanced unmanned systems to boost overall mission effectiveness. A key part of this setup is the Common Multi-Mission Truck, or CMMT. It's a low-cost cruise missile option priced around $150,000 per unit, with a range of more than 500 miles. This opens up new tactical options for mission planning and execution. Unmanned systems are changing the way aerial missions are carried out. A single F-35 will be able to control and coordinate up to 8 drones at once through AI-driven systems that handle real-time calculations and decisions. This marks a shift in strategy from solo aircraft missions to networked operations that combine human input with automated precision. The Kratos XQ-58 Valkyrie is one of the more advanced drones being developed to operate alongside modern fighter jets. With a unit cost of about $4 million, it is built to support F-22 and F-35 aircraft during complex missions that involve coordination between manned and unmanned systems. Its design includes stealth-focused features like a sharp-edge frame, a V-shaped tail, and hidden air intakes that help lower its radar visibility and improve performance in hostile environments. The aircraft is capable of flying solo or as part of a coordinated drone group. Its deployment options are adaptable, with the ability to launch from trucks, containers, or naval ships based on mission needs. At the same time, upgrades are being developed for F-35 jets to improve electronic warfare systems aimed at strengthening coordination with unmanned platforms during advanced operations. These advancements are part of the Pentagon's broader plan under the Penetrating Affordable Autonomous Collaborative Killer Program, or PAK. The goal is to develop cost-effective systems that deliver strong performance in combat scenarios. Although the Valkyrie measures only about 30 feet in length, it can carry up to 1,200 pounds of weapons, making it a valuable asset in combined operations involving both crewed and uncrewed aircraft. The payload capacity of the aircraft supports a range of munitions based on mission needs, including precision-guided missiles for targeted strikes and area effect weapons for broader tactical use. This adaptability allows commanders to adjust drone configurations as battlefield conditions change without needing separate aircraft types for each scenario. A major step forward in drone integration with F-35 jets and future next-generation air dominance fighters is the development of collaborative combat aircraft, or CCA. These unmanned systems are being built to operate alongside crewed platforms like the F-22 and F-35, handling a range of missions such as air-to-air engagements, electronic jamming, intelligence collection, and precision strikes on ground and naval targets with high levels of coordination. Collaborative combat aircraft are a leap beyond earlier loyal wingman drone designs, which relied heavily on human control. These new systems are equipped with advanced AI, allowing for full autonomy, quick adaptation to mission changes, and lower costs compared to conventional military jets. The United States Air Force is aiming to field around 1,000 of these drones, 600 paired with 300 F-35s and 400 supporting 200 NGAD fighters. That number could grow to more than 2,000, depending on how many drones each aircraft can handle during missions. Lockheed Martin is changing the trajectory of the F-35 Lightning with plans to bring in 6th-generation technology from the Next Generation Air Dominance program. CEO Jim Taiclet confirmed that the upgrades will push the jet's capabilities beyond its current level, aiming for what he calls 5th Generation Plus. The overhaul includes integrating cybernetics across the aircraft's systems and looking into a fully unmanned version that could fly without a pilot on board. One of the most talked about moments from the CEO's announcement was a challenge issued to Lockheed Martin's engineering teams. The target: deliver 80% of 6th-generation capability at half the cost. That statement has stirred debate across the defense sector and among aviation analysts, signaling a major change in how future combat aircraft might be developed and funded. The idea centers on turning the F-35 into what some in the industry are referring to as an NGAD Light, a version that offers many of the advanced features expected from 6th-generation fighters, but at a lower cost. That approach could make it viable for more military buyers. Lockheed Martin has emphasized that it isn't trying to go head-to-head with Boeing for the official NGAD contract. Instead, the focus remains on upgrading the F-35, which continues to be a key part of the company's defense lineup and a major source of revenue. Lockheed Martin's strategy makes use of its current experience and manufacturing setup, sidestepping the expense and uncertainty tied to building a brand new aircraft. This method of upgrading the jet has led to comparisons within defense circles to high-performance cars, with some referring to it as the NASCAR or Ferrari version. The label highlights how the existing airframe is being enhanced with advanced tech drawn from both the F-35 and NGAD programs. The upgraded jet is expected to benefit from the same advanced systems being built for 6th-generation fighters. That includes hypersonic weapons capable of striking at extremely high speeds, laser-based defenses designed to counter incoming threats, and sensor suites that offer a high level of situational awareness during operations. The new technology being added to the jet brings up a key question. If it can match the capabilities of 6th-generation jets like the NGAD, is there still a need to build those next-gen platforms from scratch? This could change military planning, not just in the United States, but also among allied countries already flying the F-35. Upgrading current fleets might be a more practical option than investing in entirely new aircraft, especially when cost and export limitations are factored in. The F-35 packs some seriously advanced mission systems that make this fighter jet stand out from everything else in the sky. The whole setup revolves around getting all the different sensors and avionics to work together, creating what's basically a super enhanced view of everything happening around the aircraft. At the heart of it all sits the Northrop Grumman AN/APG-81 radar, an active electronically scanned array system that does way more than just detect targets. This actually doubles as part of the electronic warfare suite, which is pretty clever engineering when thinking about it. The electronic warfare game gets handled by the BAE Systems AN/ASQ-239 Barracuda system, designed to mess with enemy radar and communications. Then there's the really cool Northrop Grumman/Raytheon AN/AQ-37 system. They call it the Distributed Aperture System, or DAS. This creates a 360-degree view around the aircraft using multiple sensors. For targeting, Lockheed Martin built the AN/AAQ-40 Electro-Optical Targeting System, or EOTS for short. Communication and navigation get covered by the Northrop Grumman AN/ASQ-242 CNI suite. That's communications, navigation, and identification all rolled into one package. What makes all this technology really special isn't just the individual pieces, but how everything connects together. Instead of having separate systems doing their own thing, The F-35 fuses all this sensor data into one complete picture of what's happening in the local area. The pilot gets this enhanced situational awareness that previous generation fighters just can't match, and the whole aircraft becomes part of a larger networked combat system. Most of the F-35 software got built using C and C++ programming languages, though the developers also grabbed some ADA83 code from the F-22 program. The Block 3F software package ended up with 8.6 million lines of code, which gives a sense of just how massive this system really is. The whole jet runs on Greenhill's software, Integrity DO-178B. That's a real-time operating system designed specifically for critical applications. This RTOS handles the integrated core processors, while data gets moved around using IEEE 1394B and fiber channel connections. The avionics design took a smart approach by using commercial off-the-shelf components wherever possible. This COTS strategy makes upgrades way cheaper and gives more flexibility down the road. The software-defined radio systems are a perfect example. Fleet-wide software updates become much easier to roll out when the hardware foundation uses standard components. But here's the thing that really caused headaches during development: the mission system software, especially the sensor fusion parts. Getting all those different sensors to talk to each other and create one unified picture turned out to be incredibly complex. This software challenge became one of the biggest technical hurdles in the entire program and ended up causing major delays that pushed back delivery schedules for years. If Lockheed Martin released a significantly upgraded F-35 to the market, it's expected that many countries would move quickly to secure orders. The cost-to-capability ratio would make it a strong alternative to developing homegrown platforms or waiting for export versions of sixth-generation fighters. Even if Boeing and its collaborators roll out an exportable NGAD, questions remain about whether the pricing would allow for widespread adoption among allied air forces. Lockheed Martin's plan hinges on whether its engineers can turn the CEO's claim of building a sixth-generation F-35 at half the usual cost into a working product. There's still debate over whether that goal is realistic or just corporate optimism that doesn't match the challenges of developing high-end military aircraft. The defense sector will be paying close attention to see if this concept moves from idea to execution and whether it changes the way air forces think about modernization going forward. The F-35 is more than just a fighter jet. Designed to meet the diverse needs of the United States military and its allies, the F-30 Lightning II is definitely a major leap in terms of stealth, versatility, and cutting-edge technology. However, recent news about a new prototype has sparked global buzz, and aviation fans everywhere are curious. Is the US secretly testing a more advanced version of the F-35? And what makes this aircraft one of the best fighters in the world? Join us as we unveil the shocking capabilities of the United States' top-secret F-35. The F-35 is often seen as a sleek and high-tech fighter jet designed with a strong focus on stealth and precise, targeted missions. This reputation is mostly accurate. The F-35 belongs to the fifth generation of fighter aircraft, equipped with advanced software that improves how it shares data and connects with other systems. It plays a vital role in modern air forces due to these cutting-edge capabilities. Lately, there's also been buzz about a rumored new version of the F-35 that President Donald Trump recently mentioned. According to Trump, this version, called the F-55, would feature two engines and be a much more powerful upgrade over the current F-35. He also spoke about an F-22 Super version of the Raptor jet. But the question remains, how true are the rumors of these interesting upgrades? Let's get into it. Back in the year 2000, if someone had claimed they could build a fighter jet that was stealthy, could take off and land vertically, and fly faster than the speed of sound, most experts would have said it was impossible. According to Tom Burbidge, who led Lockheed Martin's program from 2000 to 2013, the idea of putting all those high-tech features into one aircraft seemed out of reach at the time. Thanks to technological evolution, nothing is impossible. The fighter jet was designed to meet the needs of several military branches by combining advanced features into a single, powerful aircraft. The goal was to make it easier for different forces to share parts, training, and maintenance routines. while still having a jet that could perform well in many types of missions. It was also built to include stealth technologies first used in the F-22 Raptor. Now, Lockheed Martin is planning to take the aircraft to a whole new level. Imagine a future where F-35 fighter jets don't even need pilots to fly them, where these planes can carry out missions all on their own, smarter and stealthier than ever before. That future might be coming sooner than you think. Lockheed Martin is working hard to keep the F-35 jets powerful and useful for many years by adding new technology and upgrades inspired by their latest, most advanced fighter jet program. Even though Lockheed didn't win the competition to build the brand new 6th-generation fighter for the U.S. Air Force, the company learned a lot. They are now using that knowledge and technology to improve the F-35. These upgrades, sometimes called the Ferrari or NASCAR upgrade, could give the F-35 new coatings and better systems while keeping the same basic shape or chassis of the aircraft. The company believes this could make the F-35 almost as capable as a 6th-generation fighter, but for much less money. But whether this bold claim is true still remains to be seen. Lockheed Martin's CEO, Jim Taiclet, recently spoke about these plans at a big industry conference. He said that within 2 or 3 years, the world might see important improvements in the F-35's abilities as some of the new technologies from the 6th-generation program are added. The Air Force has already chosen Boeing's new design, called the F-47, as its next top fighter. But Lockheed isn't giving up on the F-35. One challenge is that upgrades can't just be thrown in all at once. Taiclet explained that any new equipment or software must be added carefully over time so they don't interrupt the steady production of the jets. This slow, steady approach will keep the F-35 flying without delays. Some of the exciting upgrades being considered include new types of coatings on the plane's surface. These new coatings could help the F-35 become even stealthier by better hiding it from enemy radar and heat sensors. The U.S. military has been secretly testing shiny, mirror-like coatings on F-35s and other stealth fighters like the F-22 Raptor and the older F-117 Nighthawk. These coatings make it harder for enemies to spot the jets, giving pilots a big advantage in combat. Besides the upgrades, Lockheed Martin revealed that interest in the F-35 remains very strong worldwide, and even hinted that new countries might soon join the club of F-35 users, with places like Saudi Arabia and India possibly buying the jet in the future. Jim also recently shared some exciting ideas about possible big changes coming to the F-35 fighter jet. He mentioned that the company is looking at ways to improve the very shape and core parts of the jet, things like the engine air intakes and exhaust nozzles. These parts are very important for stealth fighters like the F-35 because they affect how easily enemy radar can spot the aircraft. The F-35's backside, especially around the engine exhaust, is known to be a weak spot when it comes to stealth. If Lockheed can improve this area, it would make the jet even harder to detect by enemy radar systems, which are becoming more advanced and dangerous. Even small improvements to the jet's shape could make a big difference in helping the F-35 stay hidden in the skies. But these aren't the only upgrades being considered. Jim also talked about other important advances, including electronic warfare, better networking between aircraft, and even adding more autonomous features to the F-35. Autonomy, or the ability of the jet to fly and fight on its own without a pilot, is especially exciting. He said this is a really critical area and believes that a pilot-optional version of the F-35 might be possible within a relatively short time. While Taiclet didn't go into all the technical details about how they would make the F-35 pilot optional, it seems doable. The F-35 already has advanced digital systems and an open, flexible computer setup that makes adding new technology easier. This means Lockheed Martin could potentially design a version of the F-35 that can fly missions by itself or with a pilot on board, depending on the need. However, it's still unclear how useful this pilotless version would be. The idea of sending a jet into dangerous places without risking a pilot is appealing, but there are questions about how much benefit this would actually bring in real combat situations. Meanwhile, the F-35 is already scheduled to get big improvements in electronic warfare, the technology used to jam enemy radars and communications, as part of its upcoming Block 4 upgrade package. This package will bring new weapons, better sensors, and stronger software to the jet, keeping it up to date with modern threats. But high-tech systems alone don't make the F-35 a top-tier jet. Its core design also plays a major role in its success. The F-35 was built to be stealthy from the start. Its shape and materials help it avoid radar detection, making it harder for enemies to track and attack it. It uses one powerful F-135 engine that can push the aircraft to speeds up to Mach 1.6. When the afterburner is turned on, the engine produces 40,000 pounds of thrust. This gives the F-35 the speed and strength it needs in combat. Inside the F-35, the cockpit has been redesigned to feel more like modern technology than older fighter jets. Instead of using lots of buttons, switches, and gauges, it features large touchscreens that are easier to read and operate. One of its most advanced features is the helmet-mounted display system, which gives the pilot real-time information right in the helmet visor. This system also allows the pilot to see through the aircraft using a set of 6 infrared cameras placed around the plane, known as the distributed aperture system. This gives the pilot a full view of the surroundings, improving safety and awareness in combat. Despite facing challenges and doubts during its development, the F-35 has become one of the most advanced and capable fighter jets in the world today. With its stealth, speed, powerful weapons, and high-tech cockpit, it shows how far military aircraft design has come in combining versatility with cutting-edge technology. However, this view tends to overlook one of the F-35's greatest strengths: its flexibility. Many people don't realize that this aircraft is not limited to stealth missions alone. It is actually a multi-role fighter, meaning it can perform different types of missions depending on what is needed. One of the most surprising features of the F-35 is its ability to switch roles and carry a much heavier weapons load. This transformation is referred to as going into beast mode. In beast mode, the F-35 puts aside its focus on being hard to detect and instead takes on a more aggressive form. It loads up with weapons on both internal and external points, sacrificing some stealth in exchange for sheer firepower. This makes the jet look less like a secretive hunter and more like a powerful, heavy-hitting warplane. This mode is especially useful when the goal is not to sneak into enemy airspace, but to overpower it. By design, the F-35 is built to carry out missions in dangerous and contested areas where the enemy has strong defenses. Its stealth features allow it to slip in, strike, and get out before being detected. In fact, one of its main jobs is to gain control of the skies at the very start of a conflict. To maintain this stealth, the F-35 normally carries its weapons in an internal bay hidden within the body of the aircraft. This helps keep its radar signature low and makes it harder to spot. However, there's a trade-off. The internal space is limited, so the number of weapons it can carry in stealth mode is restricted. That's where beast mode becomes valuable. Once the enemy's air defenses are weakened or gone, the F-35 can switch to carrying weapons externally, adding more firepower and expanding its role in the battle. The F-35 is famous for being stealthy, especially when it carries its weapons inside the jet's body. In this mode, known as stealth mode, it's very hard to detect on radar. However, this stealth comes at a cost: limited firepower. In stealth mode, the F-35 can only carry 5,700 pounds of weapons. The smaller load helps the plane stay hidden from enemy radar. But once the skies are clear, meaning enemy air defenses, radar systems, and enemy jets are gone, stealth is no longer as important. That's when the F-35 can switch to beast mode. In this mode, it's no longer trying to stay invisible. Instead, it carries a full load of weapons both inside and outside its body, making it a flying powerhouse. While beast mode gives the F-35 serious firepower, there is one drawback. The jet becomes easier to spot on radar, and its range drops to around 9,400 kilometers, about half of what it can do in stealth mode. At first, using a high-tech, fifth-generation fighter like the F-35 as a simple bomb truck might sound odd. After all, older aircraft like the F-16 or B-52 were made for that kind of mission. But when you think about the cost of the F-35 program, about $1.7 trillion, it makes sense to get as much use out of the jet as possible. The F-35 isn't just a stealth fighter for day-one missions. the U.S. military often finds itself in long, drawn-out missions, not just quick airstrikes. After the early days of a war, when air defenses are gone, the jet still needs to carry out missions like ground attacks and support. In those moments, the ability to enter beast mode becomes valuable. So while the F-35 is one of the most advanced fighter jets ever built, it's also flexible. It can sneak into enemy territory without being seen or, when needed, show its full strength and carry a massive amount of weapons. Beast mode shows that the F-35 isn't just a high-tech marvel, it's also a tough and ready fighter that can handle many different missions. Jim Taiclet recently talked about exciting plans to bring new technology from the Next Generation Fighter program, called NGAD, into the F-35 jet. This could include adding new weapons that are being developed for the more advanced 6th generation fighter. These upgrades would help make the F-35 even stronger and more advanced. Taiclet described the idea of turning the F-35 into a 5th Gen Plus version, meaning it would be much better than the current model but not quite as advanced as a full 6th generation fighter. This idea isn't new. Taiclet first mentioned it back in April after Boeing won the NGAD competition with their new F-47 fighter. Back then, he called the plan a Ferrari or NASCAR upgrade, meaning the F-35 could get a big performance boost without needing a full redesign. What makes this plan really interesting is Taiclet's goal to deliver about 80% of the capability of a 6th generation fighter, but at only half the cost. This would be a huge deal because building and operating new fighter jets is very expensive. Getting most of the benefits for much less money could change the way the military buys and uses fighter jets. At a recent conference, Taiclet repeated this 80% capability at 50% cost target, saying Lockheed Martin is actively working on it and has already shared some ideas with the U.S. government. While this is an ambitious goal, the company is serious about trying to make it happen. There are also plans in place for similar upgrades for the F-22 Raptor. The F-22 is already one of the most advanced fighter jets in the world and is set to get some important improvements soon. These include a new infrared defensive system to better protect the plane, better sensors, and stealthy fuel tanks that make the jet harder to spot by enemy radar. The work on upgrading the F-22 has also helped the company learn and develop new tech that feeds into the NGAD program. Many aviation enthusiasts often wonder which aircraft would win an aerial encounter, the F-22 or the F-35. In a past interview, retired Marine Corps officer and combat pilot David Burke shared his insights with the national interest, offering a closer look at this much-debated topic. His experience is unique. Burke flew FA-18 in combat zones, trained with F-22 Raptors, and even became the first operational pilot of the F-35B, leading the Marine Corps' first F-35 squadron from 2012 to 2014. The F-22 Raptor and the F-35 Lightning II are both advanced 5th generation fighters, but they were designed with different goals in mind. The F-35 is a single-seat, single-engine stealth fighter built for multi-role operations. In contrast, the F-22 is a twin-engine air superiority fighter built specifically for one job: to dominate the skies. In terms of stealth, the F-22 is considered the stealthiest fighter ever built, with a smaller radar signature than the F-35. When it comes to aerial combat, particularly dogfighting, the Raptor is unmatched. That's because it was purpose-built for air dominance, with super maneuverability, extreme speed, and high-altitude performance. The F-35 was never intended to match those traits. As Burke and other analysts have pointed out, the F-35's strength lies in its sensors, stealth, and multi-role capability. It's an advanced strike aircraft designed to survive in contested environments, not an air superiority jet. In fact, its aerodynamic performance is often compared to the F-16, not the F-22. Still, that doesn't mean the F-35 is weak. Against non-stealthy aircraft, it performs well, especially thanks to its advanced radar, electronic warfare systems, and sensor fusion. During large-scale battles, the Air Force expects F-35s to fill in the gaps between waves of Raptors, offering vital support and striking power. Veteran Marine Corps pilot David Burke even referred to the F-35 as the most prolific 5th-generation aircraft in the world. One of the key advantages is its information capacity. It's not just about flying fast or staying hidden. The F-35 can gather, process, and share information like no other fighter. That alone gives it a battlefield advantage. The jet can collect data from across the RF spectrum, as well as from electro-optical, infrared, and laser sources. This wide range of sensing capabilities allows it to operate more effectively and across a larger area than any of its peers. But according to Burke, what truly sets the F-35 apart is not just its ability to gather data, but how it fuses and shares it. Unlike older aircraft that act mostly as standalone systems, the F-35 is part of a broader, connected network. It takes all the incoming data, processes it for accuracy and clarity, and shares it with other jets, sensors, or ground stations. This turns the F-35 into more than just a fighter. It becomes a key node in a larger information system, enhancing the situational awareness and effectiveness of an entire force. He compares its role to that of a quarterback, not just participating in the battle, but directing the play. The F-35 is designed to lead the fight, guiding other systems in the air and on the ground with real-time information. This gives commanders a clearer view of the battlefield and helps allied forces react faster and smarter than the enemy. Burke also stressed the aircraft's ability to operate in high-threat areas. Its stealth design, combined with anti-access and area denial capabilities, allows it to go where enemy defenses are strongest and still succeed. He said that the F-35 can fight in spaces where the enemy doesn't want us to be. Because of its strong sensing and sharing capabilities, the F-35 is also capable of operating independently when needed. It doesn't need to rely on support from other aircraft. Instead, it can pass on what it sees to others, even outside normal communication ranges. Burke, the only Marine to have flown both the F-22 and the F-35, concluded that the key question is not how much it costs, but what it delivers in return. In his view, the F-35's unique features and unmatched capabilities more than justify the investment. As the Russo-Ukrainian war continues to wage on intensely, Russia has made a daring move that no one saw coming. This country just unveiled a $300 million fighter jet packed with incredible speed and devastating firepower. Built to dominate the skies, this jet is not only faster but also highly agile, with the potential to engage and outmatch even the advanced American F-35 in aerial combat. What makes this fighter jet so unique? Could it really subdue the F-35? Join us as we explore the groundbreaking features of Russia's insane new $300 million fighter jet that can destroy the F-35 in seconds. The Sukhoi Su-75 Checkmate, also known as the Checkmate, is an impressive new addition to the world of fighter jets. Designed by Russia, this jet is built to be fast, stealthy, and loaded with advanced technology. The Checkmate is a fifth-generation fighter jet that can compete with other powerful aircraft like the US-made F-35. The goal with this fighter jet is to appeal to countries that need a capable, modern fighter, but don't have the enormous budgets required for more expensive jets. This approach makes this aircraft an interesting one in the fighter jet market. What makes this jet unique is its focus on stealth technology, which makes it hard to detect by enemy radar. The engineers who designed it worked carefully on its shape, using special angles and materials to reflect as little radar energy as possible. This means the jet has smooth surfaces and a carefully designed body that deflects radar waves, making it much harder for enemies to spot. Instead of hanging weapons on its wings, as many older jets do, this aircraft hides its weapons inside the aircraft. This hidden design doesn't just help with stealth, it also reduces drag, which lets the plane fly faster and with greater maneuverability. Unlike many modern fighter jets, this fighter aircraft uses a single-engine design. Most advanced fighters, like the F-22 and Su-57, use two engines to reach higher speeds and handle heavier loads. But a single-engine design makes it cheaper to produce and maintain, which lowers its overall operating costs. Despite having only one engine, this jet is very fast and agile. It is powered by a version of the AL-41 F1 engine, which is a powerful and reliable engine used in other Russian jets. This engine can potentially allow the jet to reach speeds of up to Mach 1.8, letting it keep up with other fifth-generation fighters while using less fuel. Its cockpit is designed to help the pilot handle fast, complex situations with ease. It features a high-tech interface that gives the pilot important information about the aircraft, surrounding threats, and mission details, all showing on a single screen. The pilot can even use voice commands to control certain systems, meaning they can keep their hands on the controls without needing to look down at buttons or switches. This type of advanced, user-friendly cockpit makes it easier for the pilot to focus on tactics and decision-making during missions, enhancing both safety and efficiency. The jet's advanced radar system also adds to its capabilities. Using what's known as an electronically scanned array radar, it can track multiple targets at once, identifying and monitoring enemy aircraft or other threats from a significant distance. This radar system is similar to the one found on Russia's Su-57, giving it the ability to detect targets well before they get close. In combat, this long-range radar allows the pilot to see threats from afar, decide on a plan of action, and engage or evade before the enemy is even aware of its presence. This advanced radar capability is essential in today's aerial combat, where quick reaction times and early detection are crucial. Designed for flexibility, this fighter jet is built to handle a wide range of missions. Whether the mission is focused on air-to-air combat, ground strikes, or surveillance, it can adapt. This flexibility is partly due to its modular design, which allows operators to change certain parts based on the type of mission. If a mission requires more firepower, the checkmate can be equipped with additional air-to-air missiles. And if the mission involves attacking ground targets, it can be equipped with precision-guided bombs. This makes it a versatile tool, ready to take on a variety of roles based on the needs of the mission. The aircraft's weapons system includes a mix of missiles and bombs that can be designed to suit different situations. In air-to-air combat, this fighter aircraft can carry short and long-range missiles, giving it the ability to engage targets both close-up and at a distance. For ground attacks, it can carry bombs with precision guidance technology, allowing it to strike specific targets with high accuracy. This mix of weapons makes it really effective in both air-to-air and air-to-ground roles, providing a well-rounded set of capabilities that makes it useful in diverse combat scenarios. In close-range fights, where agility and speed are essential, this aircraft can perform well. One key feature that gives it an edge is its thrust vectoring, a technology that allows the engine's exhaust to be directed in different ways. This directional exhaust provides greater control and allows the jet to make sharper turns, giving it an advantage when maneuvering against enemy fighters. By adjusting the direction of the engine thrust, the pilot can quickly change the jet's position, helping them outmaneuver opponents during intense aerial engagements. Maintenance cost is another area where the checkmate stands out. Many advanced fighter jets are incredibly expensive to maintain due to their complex systems and high-tech materials. However, this jet has been designed with simpler, more reliable components that make maintenance easier and less costly. This has been a big selling point for countries with smaller defense budgets, as it reduces the lifetime cost of operating the jet. One thing that makes this fighter jet so appealing is its strong focus on digital technology and automation. It is also equipped with artificial intelligence assistance systems, which will give the pilot a powerful advantage. These AI systems can analyze vast amounts of data in real time, offering suggestions to the pilot, or even making tactical decisions independently when needed. The AI could track multiple targets simultaneously and provide the pilot with the best options for attack or evade. This capability makes it highly efficient in combat, allowing the pilot to focus more on strategy rather than on manually managing every system. The checkmate's software and systems are designed with future upgrades in mind, meaning it can easily incorporate new technology over time. This ability to upgrade is significant as military technology is advancing rapidly, and a fighter jet can quickly become out of date if it isn't adaptable. By creating a design that can be updated with new hardware and software, Sukhoi is ensuring that this aircraft can stay relevant for decades. In the long run, this adaptability can save operators money, as they won't need to replace their jets every few years. They can simply upgrade their jet as new advancements in radar, sensors, or AI become available. Its stealth capabilities have always been its most impressive features, as there has been more significant effort into making this jet difficult to detect. Aside from its radar-evading shape, the jet is constructed with radar-absorbent materials that further reduce its visibility to enemy radar systems. These materials are carefully chosen to absorb radar waves rather than reflect them, which minimizes the jets being seen on enemy screens. Another aspect that makes this powerful aircraft stand out is its potential for carrier operations. The Checkmate jet is modified to take off and land on aircraft carriers, making it one of the rare single-engine stealth fighters able to operate from carriers. This carrier version can provide a cost-effective stealth option for naval forces, allowing them to project power far beyond their home bases. Being adaptable for aircraft carriers adds extra flexibility, making it a fighter jet that can operate in different environments to protect airspace over both land and sea. This powerful aircraft also has a low infrared signature, which means it's less likely to be detected by heat-seeking missiles or sensors. Its engine and exhaust are designed in such a way that they emit less heat than traditional jet engines. Lower heat emissions make it harder for enemy infrared sensors to track this jet, reducing the chance of detection by thermal imaging systems. This low-heat design is part of what makes this aircraft valuable in missions where remaining undetected is essential, such as reconnaissance or precision strikes. By combining low radar and infrared signatures, it can evade both types of detection methods commonly used by enemy forces. The jet's fuel efficiency also sets it apart. Due to its single-engine design and carefully streamlined body, the aircraft can fly for extended periods without needing to refuel. Long-range capabilities are essential for countries with vast territories or those that need to patrol large areas without frequent refueling stops. The fuel efficiency is also advantageous in combat scenarios, as it enables the aircraft to stay in the air longer, providing better support to ground troops or staying alert to enemy threats over extended periods. This extended range and endurance make it especially appealing to countries with large areas to cover. Beyond its technical capabilities, its low cost and ease of use make it appealing for joint training exercises and cooperative missions with allied nations. Many countries with limited defense budgets might find it easier to operate and maintain this fighter jet than some of the other fifth-generation fighters. This accessibility allows for more collaborative defense programs, where multiple countries share training resources or develop combined air strategies. By choosing a fighter like the Checkmate, which is easier to acquire and manage, these countries have enhanced their defense partnerships, contributing to regional stability and security. Using the F-35 as a comparison might not be the best choice because this jet has faced many challenges from its design stage to full production, and it is nowhere near the Checkmate. To understand why, let's take a closer look at the F-35 project. The F-35, also known as the Lockheed Martin F-35 Lightning II, was created to be the world's most advanced stealth fighter. Developed by the United States, this aircraft was supposed to replace older models and bring revolutionary capabilities to the battlefield. However, the path to making it work has been full of problems, delays, and high costs. Designed to serve multiple branches of the U.S. military, the F-35 aimed to be a one-size-fits-all fighter, which meant it needed to perform a wide range of tasks for the Air Force, Navy, and Marine Corps. But that ambition quickly turned into one of the most complicated and expensive military projects in history. One major reason the F-35 became so complex is that it was built in 3 versions, having the F-35A for conventional takeoff and landing, the F-35B with short takeoff and vertical landing for the Marines, and the F-35C for aircraft carrier operations for the Navy. Each version had to meet different needs, making it difficult for engineers to design a single jet that could perform so many roles. This challenge led to technical issues and increased the time and money required to bring each version to life. One unique feature of the F-35 is its advanced stealth technology, designed to make it nearly invisible to enemy radar. Its special shape and materials help reduce its radar signature, so it's harder to detect in combat. While this stealth capability gives the F-35 an edge in sneaking past enemy defenses, it also makes the jet more expensive to maintain. The materials that reduce its radar signature are delicate and require careful handling, meaning that any minor damage could compromise its stealthiness. The F-35's cockpit is another high-tech aspect that was supposed to make it revolutionary. Instead of traditional gauges and dials, the F-35 relies on a massive touchscreen display and a helmet-mounted display system. The helmet itself is a piece of technology worth noting, as it provides the pilot with a 360-degree view, allowing them to see through the aircraft as if the jet itself were invisible. This high-tech helmet, however, came with its own set of problems. Priced at hundreds of thousands of dollars per unit, it's also heavy and uncomfortable, leading to concerns for pilots, especially in high-stress combat scenarios. For all its cutting-edge features, the F-35 has faced criticism for performance issues. One major drawback is that it can't fly at twice the speed of sound as some other jets can. In fact, the F-35's supersonic flight mode is limited to brief bursts, and there's even a warning on its control panel advising pilots to use it only in emergencies. While it's still fast, this limitation restricts its ability to perform at the speeds that many other fighter jets can reach, which could be a disadvantage in high-speed air combat. Additionally, the F-35 relies heavily on complex software to function, with millions of lines of code running its systems. This reliance on software has led to frequent glitches and has made the jet more prone to technical issues. The software complications mean that the F-35 often needs updates and troubleshooting, which has slowed down its deployment and made it harder to keep ready for action. In combat situations, any software problem could potentially limit the jet's effectiveness, raising questions about its reliability on the battlefield. The F-35 is also known for being costly to maintain. The price tag of around $80 million per jet and the maintenance costs add up significantly over time. The advanced stealth coatings need constant care, and any repairs to their sensitive technology require specialized tools and expertise, further driving up costs. This high upkeep has made it challenging for some countries to justify the expense, even if they were initially interested in purchasing the jet. Another problem that has troubled the F-35 is its ability to be ready for missions. The aircraft has faced problems with reliability, and many units have been taken out of operation for repairs at any given time. Its engine, while powerful, has faced issues, including failures in its heat-resistant coating, which can lead to expensive repairs. These maintenance delays mean that not all F-35s are flight-ready at the same time, reducing the fleet's overall effectiveness in large-scale operations. Despite these setbacks, the F-35 does have impressive weapons. It can carry a range of missiles and bombs, with an internal weapons bay that allows it to remain stealthy while still being powerful. For missions where stealth isn't as critical, it can also carry additional weapons on external mounts. This flexibility in armament allows the F-35 to perform both air-to-air and air-to-ground attacks, making it a versatile choice for a variety of missions. One of the most innovative aspects of the F-35 is its ability to gather and share information with other units in real time. It can connect with other F-35s and allied forces, creating a networked view of the battlefield. This data-sharing capability is a huge advantage, as it enables coordinated attacks and improves situational awareness for the entire team. This networked warfare concept is part of what makes the F-35 valuable, even if it has faced issues along the way. However, as advanced as it is, the F-35's development and operational issues have left room for other nations to step up with alternative options. Russia's Checkmate fighter is quickly becoming a better choice for countries looking for a new military aircraft. Many nations are turning away from the F-35 because of its high costs and complicated technology. The Checkmate's designers have even considered future updates to keep the jet competitive in a changing world. The Russian aircraft company has mentioned the plans to create an unmanned version of the Checkmate, which would allow it to be used as a drone. In this unmanned mode, it could fly missions without a human pilot, potentially being controlled from a base far away. This capability would be useful for high-risk missions where sending a human pilot might be too dangerous. The possibility of an unmanned development shows that the country is thinking ahead and aiming to keep the aircraft relevant for future warfare needs. It has also been that a two-seater version of the Checkmate will be developed soon. This development would allow for a co-pilot or systems officer to join the mission, providing additional support in high-stakes operations. The second crew member could take charge of managing weapon systems, communications, or electronic warfare, allowing the main pilot to focus entirely on flying and tactics. A two-seater variant would be useful for complex missions that require extensive multitasking or coordination with other units, giving air forces even more flexibility in mission planning. This fighter aircraft represents a significant shift in fighter jet design philosophy. By balancing affordability with advanced technology, it is also challenging the traditional fact that fifth-generation fighters must come with sky-high price tags. With this jet, countries that could not previously afford fifth-generation technology now have a potential entry point into the world of stealth and digital warfare. This shift could have a lasting impact on global air combat, making advanced air capabilities accessible to more nations, and, in turn, reshaping military strategies around the world. The Sukhoi Su-75 Checkmate is more than just a new fighter jet. It represents a new approach to fighter design, one that combines stealth, versatility, and affordability. With its AI-driven systems, stealth capabilities, adaptability for various missions, and future-focused design, it has the potential to make fifth-generation combat technology available to a broader range of countries. By providing a fighter jet that balances advanced features with cost-effective operation, this fighter jet could redefine the expectations for modern fighter jets in the years to come. Russia's Checkmate fighter jet isn't just a new player in the aviation world, but it's built with the ambition to outmaneuver and outperform, especially against competitors like the F-35. Packed with features that blend stealth, speed, and striking power, the aircraft is designed to capitalize on the weaknesses of the F-35 and to dominate in combat scenarios where every second counts. Thanks for watching. While you are still here, click on the link appearing on your screen to check out another of our videos. See you there.